Okay, what we have here is the conversation between Annalie and the mini-me on complexity. What I'm going to do is kind of start with kind of the premise and give kind of a short issue about complexity since I only missed the complexity presentation. And we'll start with the fact that, if you look at the bottom here, we basically solved most of the what are called common and complicated problems. Normally they can be solved with best practice, and most of them have been solved to date. So what we're really doing here is we're kind of raising the bar, and we're going after things like what matters and what works, complex and chaotic problems. So we're finished in my mind. If you look at a kind of what is called a bell-shaped curve for problems, we're pretty much finished with the ones that are in the middle. And what we're really doing now, we find the complex and the chaotic problems really sit out here on the ends, with the complex, let's say for argument's sake, the complex being the purple and the chaotic being even the smaller tips of the ends of that bell curve. And so what we're trying to do is, and if you take an example, let's take a scientific example. All right, what we're finding at the microscopic level is that in nanotechnology, we're finding that even things at that small size actually defy the laws of gravity. So some of the things that really make everything else work in the middle, if you will, don't work at the ends. And we're finding the same thing when we get at the global level. If we look at the universe, things that we're learning about the universe, things that we have to apply to make sense out of what we're learning from the universe are not things that we need in order to function in the middle and in what we're doing in our everyday common event. So the scientific is different. If we look at the social is different. What has happened is that we've come up with systems and institutions that are very good at addressing the small groups in the middle. What they're not good at is they're not good right now at addressing the individual. We seem to have lost the individual in many of these things. And also, they're not good at addressing, say, plurality, where we have a whole slew of people with totally different opposing opinions. So the social area is now also moving out to the complex and the chaotic, and the economic, same thing. I mean, we have we have got such a litigious society that it's difficult for us to deal with a handshake type of arrangement, which really should be workable. And then again, we're looking at the global economy. So everything that's happening in our basic scientific, social, and economic world is really driving out towards the ends. We've solved most of the big problems and most of the big issues that sit in the center. And so that's what we're talking about when we talk about the complex and chaotic. The reason that it's important, right, is that there's a heavy risk involved, and the risk intensifies as the scope goes. So, as you get global in terms of your intensity, a terminal global mistake is an existential risk, which means that it actually completely destroys everything. I mean, everybody's gone. The planet's gone. We're gone. Everybody's gone. If it's a local terminal, it's genocide. But you can see as that risk is going up as you move towards the ends of that equation of the bell curve. So we're out there, in some really dangerous territory. And then when we look at the ramifications of what we've seen, say, in the 20th century, we see that, we often, we use an elephant to kill an ant, all right? And we can see that an awful lot in our politics where one small problem and we come up with these rules that are kind of very restrictive to everybody, right? We also have kind of a one-size-fits-all methodology that we've used for an awful lot of our solutions, and that doesn't really work. In other areas where this is what they say, if you only have a hammer, every problem appears to be a nail. And I think that this is one that's kind of near and dear to Annalie, because I think that in some cases the medicine has one hammer way of looking at things, and so that it treats every problem as if it's a nail. The other is to boil the ocean, all right, and again that has some serious ramifications. And then there's whack-a-mole, which is I think a very prominent one that we see today, where we smack one mole down and another one pops up somewhere else, and we just have no idea where they're coming from. Well, think about these types of issues, using an elephant to kill an ant and whacking a mole and trying to make one size fit all, and think back of the risk, or existential risk of a problem. It creates a kind of a concern that we have to be careful about. All right, and so why is that important now? Again, because we are going out to the ends, and we're going after complex and chaotic problems. And complex problems, we have to identify what matters. All right, and so if we're trying to identify what matters, it's really important that we zero in on the fact that it's probably not just one thing. We probably have sustainability sits into a whole lot of our different issues. So we can't always be with cost, and it can't always be just that. It even just be humane. It has to be sustainable. It has to be useful. It has to be calm. There are many parameters that we want to see that sit around our issues. Now, also, when the problem is chaotic, we have to look at what works, and so the solution set for chaotic problems is really a what works solution set, which means that where hopefully our spiral is getting smaller, but we are using a spiral technology. We're taking stopping points along the way to say, did we get there? Did we get there? Is it working? But we're constantly monitoring it. So chaotic problems, insist that we have constant monitoring techniques. So what are some of the opposing forces that are working against us and working against us being successful with this? And one of them is that in the 20th century, that's why it's called the 20th century news, that the word catastrophe and disaster increased almost 500-fold in like just 20 to 50 years. So the analysis is that the politicians, the media, and the lawyers gain from this, because if they have us fearful, then we're more likely to use their services or depend upon them, and so you find the word catastrophe in the media, like I said, almost 500 times what you see it in what it was in the late 1890s or the early 1900s. What we're seeing now is that the same thing is about complexity, is that everybody is kind of bundling everything in together and calling everything complex. They're saying that the economic system is complex, and the market is complex. Everything is complex, and therefore we need specialists. And the specialists, again, I think we're getting to, when you get to the fact that every problem needs a specialist, we're down to the idea that the hammer and the nail. We've defined that a specialist now is the absolute solution for every problem, and that's not true. And so we really have to be very, very judicious about the way that we approach problems. And the theory of complexity has very specific solutions for problems. They are often complicated. They are not complicated. They are difficult. They are rigorous. And so we don't want to just use the word complexity, any time to mean anything, because it's just not true. So let's look at the framework for really, what complexity really is all about, okay? And it's an interesting thing. What was found out is that when you look at a process, and you see if you have this process that looks very, very complex, if you will, right, or certainly look complicated, it's really, you can't look at the process. There's no way to look at a process. There's no criteria that we found that looking at a process tells us that process is complex and then allows us to use tools that we would use to solve complex problems. Instead, we have to really look at the inputs and the outcomes. That's what lets us know whether we're really dealing with a complex problem. And an example of this, all right, is inputs if they're adaptive, all right? So if our process in the middle can facilitate adaptation, then we know that we're dealing with a complex problem. Now, what does that mean? Let's take an example. Let's take the example of the DNA. And if the DNA actually, if the environment was stable, and the DNA, you have this idea that the DNA is constantly replicating, and there'll be some mutant replications that wouldn't work. But if the process in the middle remains stable, then we'd have many fewer species, and the diversity would be much lower. It's the fact that the process in the middle is not stable, that the process in the middle is a moving process, like evolution, that so things are moving, and therefore you have moving input that are moving into a moving process, and so the adaptation becomes we now know that is in a very complex process, and we're going to have to use our spiral and complex process tools to go after that process and to try and solve it. So that's one of the areas. The other, so we look at the outcomes, is what they call emergence. And emergence is an interesting issue. So if this process delivers emergence, then we know that it's a complex process. And let me kind of give you a really easy example of that. If you take two hydrogens and one oxygen, you combine them and you get water. Water has an emerging property called wetness. Now, neither hydrogen nor oxygen by itself has wetness. The combination of the two of them produces an emerging feature. So if the process itself, in essence, combines more behaviors and attributes than you can get by summing all the behaviors and attributes of all the inputs, then you know that something happened inside the middle. So something happened in that process that made it so that it actually added something to it. And so now we have wetness, or we have an emergence property of the combination that is different than any of the items in and of themselves. So emergence is one of the things that we look for. So if the process delivers emergence, that we're pretty sure we got a complex process, because we can identify what it is inside that process that made something emerge. All right, let's look at the last one on this, because there's three. The last one is unpredictability. So if the process kind of also delivers unpredictability, then in essence we're looking at a complex process. And again, this is pretty easy in terms of if you sum all the inputs, the same as we said before on emergence, you sum all the attributes, everything about the input, and you cannot predict what it is that it's actually going to produce, then you know that you're really dealing with something that is very complex. And the complexity actually has a couple of issues. One is, did it become complex because of scale? All right. So as we went from to the outer limits of the universe, and the scale got to be so enormous, or the scale got to be so small in the nano universe, if you will, things got unpredictable, and so we had to apply what we call probability theory to what we think is going to happen, because the scale is beyond our normal range. The other thing is that sometimes if we look at unpredictability, we'll find that it also has to do with having more dimensions to the problem. Because we have two hands and they're opposing, we tend to treat many problems as if there's only two pieces, and they're opposing pieces or whatever. And really, most things have at least three dimensions and many more. So dimensions bring an unpredictability to it, because and it may just be that our minds are incapable of dealing with multidimensional problems, and therefore someone who actually could deal with multidimensional problems wouldn't consider it unpredictable. But for us, with our inability to deal with multidimensional problems, it is an unpredictable solution for us. All right, so we have to use probabilities for what we think is going to happen. And then the other thing is speed. And speed's a really interesting one for predictability, because speed, it's essential for something to be predictable that tomorrow equals yesterday. And that's an interesting concept, because what it says is that if I'm going to use what happened yesterday to predict what I think is going to happen tomorrow, then what happened tomorrow, that the whole environment has to be a little bit stable. But if things are moving so fast that there's no chance that me looking at yesterday to make an assumption about something that may happen tomorrow, that speed is a very, that is a very prominent element in whether we can actually predict things or not. So again, unpredictability has relationships to scale, to dimensions, and to speed. Right. So let's kind of summarize here. Let's look at this and let's say that, also because we noticed that that we're out here on the complex and we're on the outer edges, if you will, of the bell curve, is the scientific methodology still valid? So the fact that, if you think about it, if you go way narrow in there, I mean, for the longest period of time, man had religion and kind of solved most problems with religion. And then they came with the scientific method, and then they moved out in terms of the scientific method, kind of tossed the religious method out and moved out there and said, okay, we need the scientific method. And that helped us deal with problems all the way, out into the, let's say the two big ones in the middle. But is that scientific methodology still the same methodology that we should use at the extremes? And that's one of the things I'm going to bring up later when I bring up one of Annalie's questions. All right. The same thing is the democratic method. All right. Is democracy, the way we've organized democracy, is that really the methodology still valid at the extremes? And it might not be. We might have to come up with a kind of a hybrid methodology for dealing with all of the different communities that we have. And then the same thing as the capitalistic methodology still valid at the extremes. I mean, I think we're seeing in terms of the enormous disparity in wealth that the capitalistic methodology may not be valid at the extremes. And we may have solved and used capitalism for what we need it for in the middle, and we may have to build a hybrid of capitalism also, or a hybrid of the market system for the future. So our methods may be different in terms of as we move out into the outer edges of our bell curve. And so now let's look at Annalie's question. Okay, Annalie says, since my pain is complex, nobody wants to address it. Right, and so I guess maybe that's because your pain doesn't really fit any contemporary model. Now, don't forget, this is a possibility. I'm just guessing. All right, but the question then becomes, are we using the right methodology? Again, if we look at the fact that the methodology that worked for everything in the middle is not the same methodology and if we agree that it's not the methodology that's going to work on the outer edges, we may need a different methodology for going after the problems that are problems that don't fit into the middle. And I think that's a very valid question that should be asked to the whole medical profession. Is, are we going after this? Do we have the right methodology now? As we look at, let's say, we solved some of the major issues revolving around cancer. I mean, we haven't solved all of them, but we solved them. And so maybe the solutions that we need for the outer edges now are different. And we can't use the exact same techniques and the exact same philosophy and methodology on the outer edges. The other thing, Annalie said, I keep coming up with ideas and the doctor just executes them, all right? And that gets us to, if the problem really is a complex problem, then we have to find what the levers are in that complex problem. We have to find what it is that makes things different, and so we have to approach the problem that way. And we also have to look at, but if it is chaotic, we're going to have to look at it as something that what works. And those are two different methodologies that we would use to solve the problem. And it seems like we're going with actually, I don't know which methodology. You probably have used both. You've been doing this and fighting with this problem for so long. But the point is that is, we have to decide that. And then if we're looking at the chaotic one, if we get to your next question, it appears to be a never-ending job. It's paramount when solving the chaotic that the spiral be constantly circling its way down towards a target, that it can't be constantly just wavering out there. It can't be a spiral that doesn't have some kind of a way of moving towards a target. And there's techniques that we can use to go after that. Say, okay, let's work our way, on those type of things. And so that, the other thing is that, is our target a quality of life target or just good enough? I mean, many doctors really believe in a just good enough. And I'm not saying they're right or wrong, but they really believe in a just good enough. If I can get this person's, a physical body moving just good enough so that they can actually, get to a wheelchair or get to some unit that will then move them. That's really good enough. That my view, me being a doctor, is not a quality of life view. It's a just good enough view, and that may not be what your view is. And so that also changes the way that we would, the number of arrows that would pop into this spiral would change based upon, what we're using as our goals. And then the last thing you said is that your dad sees this, the nerves are similar to electrical wires. And that's a really important issue, is that the secret ingredient for analyzing and solving complexity is finding the right models. And they don't always come from the same discipline. The more we're finding in the complexity that it's interdisciplinary. We're jumping, over fences of different areas of interest to come up with things that we mix together. So if there's a good chance that your dad is onto something with regards to the fact that the nerves are similar to electrical wires, or electrical wires are similar to the nerves, however you put it. But we can, if you think about it, we can toy around with things with regards to electrical wires and see what they do, and there are characteristics and properties of electrical wires that, in my mind, and this is just my own thing, just somehow don't seem to make sense. But there are people who do know about it, and we have to cross these disciplines. And so I think that the whole idea is that complexity and complex problems, and the ones that are out at the outer edges of our curve there, are really going to require interdisciplinary, multidimensional, those types of approaches to it. So we can't use the common way of going about it. So that's how, in my mind, complexity relates to your questions. I hope that was helpful. Bye now.